This is CA7. I'm going for an M. CA7 is all about designing heat exchanger. Here, I want to solve for Q dot. I want to solve for all the temperatures. I want to solve for efficiency and surface area. You will see in the further video all the equations and methods that I use to solve. So, to start, I chose a double pipe counterflow heat exchanger. I also inserted a photo that we use in class. This kind of shows the type of heat exchanger that I'm using here. I also listed all of the givens. The U value is based on my birthday, which is December 9th, 2000. The CP value for oil, I decided to calculate at 90 degrees Celsius, which is the average of the inlet temperature and the outlet temperature, and then I proceeded to interpolate for that value. The CP value for water, I picked at 20 degrees Celsius. I chose this because when I go up to 100 degrees Celsius, it does not change a whole lot. Also, you'll notice that TC out is unknown, so I will be solving for that later in this video. So this is my slide where I solved for TC out. I knew that the Q of water and Q of oil would be equal to each other. And this I was not able to get Q dot, so there is mass flowing, even though it is not represented accurately. So as you can see, I inserted both of these equations here, and TC out is the unknown variable. After I had all of the values that I wanted, solving and using algebra was the easy part. I ended up calculating TC out as 61.6 degrees Celsius. This makes sense for a logical check because it is heating up as it leaves. So here is my efficiency. The efficiency was pretty straightforward. Q dot over Q dot max. Q dot max was easy to calculate because I want to take the biggest temperature difference. In this case, it is 100 degrees Celsius minus 20 degrees Celsius. Here I converted it to Kelvin because it is necessary. So Q dot max was equal to this large number, and Q dot I used for Q dot oil, which both of them would be the same, and I got an efficiency of 25%. The surface area. The surface area was a more complex and challenging problem. The surface area equation that I used was Q equals U times AS times the change in temperature log mean. So solving for AS, I ended up getting 0.407 meters squared. The change in temperature log mean has an equation. As you can see, I listed it out. And I listed T1 and T2. T1 is the inlet of the hot temperature minus the inlet of the cold temperature. T2 is exit of hot oil minus exit of hotter water. As you can see, I got those values and then solved.